Hey guys, welcome back to the Zenith porthole restoration project. And yeah, I took the plunge. I put the full-size CRT in, so let me catch up to speed. I basically finished the recap. I still have one electrolytic left to do. The set was playing okay, but it was looking kind of washed out and weird with the test CRT, so I wanted to install the full-size CRT to see how that would look. And I've had it running for a while, and has the same issue. In fact, it seems like it's been gradually getting worse while the set's been playing for about 5 minutes now. Meaning, if I put the contrast up high, it starts getting inverted. And yeah, so this is with the brightness all the way down. That's exactly what I saw with the test CRT. You can't kill the brightness, which is good, because there's hope. It means that I probably have some resistors out of spec or something like that. And we have some definite distortion on the left hand side here too. There's a switch here which should control how it fills. Yeah, it's a little bit taller if I throw it. It's supposed to completely fill the screen, so we're not quite there yet. And the sound is good, so got that going for us. Don't have the volume knob, so I'm going to use a screwdriver. So, carefully turn this off, because yes, this entire CRT is running at 12,000 volts, something like that, maybe 14,000. So let's just turn this off, shall we? I would turn it off with the set, but the power switch isn't working. It's not shorted out here, so I'm not sure what's going on with that. Better to be stuck on than stuck off, I figure. Alright, so we have a few issues to go after. We don't have full width, the image is compressed on the left, don't have full height, brightness control isn't working like it should, contrast control doesn't seem to be working like it should. Well, let's start out with the distortion on the left hand side, because I just remembered that I didn't replace the cap I can see in here, and I suspect there's another one down inside there. And maybe not, I can see some mica caps down in there, but for sure that guy gets a 0.01. The left-hand side of the screen is controlled by the energy recovered from the flyback action, the damper circuit, and the flyback. Now, usually there's a linearity coil with a 0.05 microfarad cap on one side and a 0.035 on the other, but this is a little bit different. I don't see that typical linearity coil with those two capacitor values. But, and the schematic is so hard to read. I do have the Sam's version, which is a little bit better. I can pull out, it's on my laptop. I don't see a 0.01 in here. But once I get that paper cover off, we'll be able to see it more. But there are definitely a couple caps down in. Oh, those are the 2.1s in parallel. Those are those two guys. So those did get replaced. Well, that's the width control. This is the width coil here, and horizontal frequency, horizontal phase. Those are those two coils there. Oh, so we're over here. So it's probably that guy, that 0.015. When we place that, is not going to, because the problem I think is with something over here. Maybe the damper tube needs to get replaced. Could be as simple as that. Brightness control, that's it's this guy, which is not exactly convenient to get at, but I can see a resistor here. I'll trace out what it goes to. Maybe we just have a resistor that's really off value. So let's start with those two items and go from there. Well, I replaced the last two electrolytics in this can, replaced the one paper cap by the horizontal circuitry, and it made no difference. You know, just randomly replacing old parts because they're old will generally only get you so far. So let's think about this a bit more methodically. There's the brightness control, minimum, maximum. It's doing something but nowhere near as much as it should. And the contrast, similarly, if I put it down all the way, image gets more washed out. If I go up higher, it gets good until I get to a point where it's also really washed out. I'm going to turn this off. So, let's think about this. There's 5 elements on the picture tube. I suspect one or more of them are wrong. The filament, we know that's good, otherwise we wouldn't have a glow and we'd have no image. The high voltage, likewise, has to be good, otherwise we wouldn't get anything. That leaves 3 other elements. The cathode, which appears is what should vary in voltage with the brightness control. That's where the electrons come out of. We have the grid, which they're using to modulate the electron flow, and the grid should always be negative with respect to the cathode, and the more negative you make it, the dimmer it gets. I suspect that's where the problem is that the voltage in the cathode or the grid is wrong, and we're not able to make it negative enough to cut off the electron flow. But there is another possibility, which is what's sometimes called G2, second grid, or A1, first anode, which is in between the high voltage up here and the grid, which normally sits at around 400 volts or so. That's there to get the electrons moving towards the screen and focus them to some extent. That could also be off or disconnected entirely, which could screw this up. So we've seen something like this twice before, if you've been following along. Once in an RCA set where there was something funky with the video, I think it was the video amp, and the grid was actually positive. And probably was potentially doing some damage to the picture tube because it was just driving it on so hard. And another time was when there was a disconnected element in my test CRT. That's one of the reasons I popped in the full-size one. It has the same problem, so I don't think the problem is in this. I think the problem's in the set. So, let's get methodical. I have, in the same as PhotoFact, a resistance and a voltage chart, which shows you what the resistance should be for every pin on every tube, including the picture tube, usually to ground, but sometimes just some other reference point, and also what the voltage should be on those pins. So let's start by checking the resistance and the voltage to those elements on the picture tube socket. The cathode, the grid, and the first anode. My printer's not working so well, so that's really hard to read. I'll bring down my laptop, but meanwhile I jotted down the 3 voltages we care about right now. So the grid should be plus 150, A1 should be plus 490, and cathode should be plus 225. Now I said the grid should be a negative voltage. I don't mean negative with respect to ground, I mean negative with respect to the cathode. So 150 is less than 225. It'd be about minus 75 volts with respect to the cathode. So let's check those 3 voltages. Okay, we got 390. What did I say? It should be 490. So we're 100 volts low on A1. Next one over. 179. That's the cathode. Should be 225. So we're off a bit. Let's see. Then filament. Should be the grid. 157. So the grid's about right, but the other 2 are low. 490 is probably derived from a boost circuit coming off the flyback. So I'll need to check that, and that affects height too. And the cathode being a bit low. Actually, let me turn that back on. So the cathode should be the one varying with the brightness control. That's 11. So that's this guy. So let's see. But at one extreme on the brightness, this is all the way down. It's 175. And as I go more positive, it goes, wait a minute, it goes from 175 to 160. It barely changes as I change the brightness. I'm trying to do the mental math here too. So the cathode. So I would think making the cathode more positive would make it dimmer, right? Yeah, okay, so when you were at the dimmest setting, it's 175, and at maximum brightness, it's at 160. So it's not going, the ranges I don't think is as much as it should be, and it's definitely not going as positive as it should be. And the boost voltage is low, so maybe the whole positive supply is running a bit lean. So let's do some checking. Let's check the main B plus voltage and go from there. Well, I seem to have solved both the brightness problem and the problem with the horizontal fold over. So it's brightness all the way down and all the way up. And contrast all the way down and all the way up. So what did I do? Well, so what did I do? I followed up with those voltage checks by going to the circuits that produce those voltages. So we had the cathode, the circuit going to the brightness control was off. Well, there's a 33K resistor going to the center wiper on the brightness control. I dug it out. It's supposed to be a 5% resistor. When I checked the lugs in circuit, I got more like 500K. However, when I took it out of circuit, it actually measures okay. Leads are a little stumpy here. Let's see if I can get my probe on there reliably. So 39K. It's a little high, but it's not wildly off. I think it was a bad solder joint. I ended up replacing it, but I think I could have just reflowed the solder and it would have been alright. So that improved the brightness voltage, but we still had the low A1 voltage, we still had the fold over. So I checked the resistors on horizontal output tube, these guys. 200 ohm resistors and two 150 ohm resistors, allegedly. However, when I check them, so here, this is supposed to be 150 ohms, and it's 283. So, almost double what it should be. This is another 150, more than twice what it should be at 324. So I said this many times, resistors being off 10, 20, 30, 40% typically are not going to cause any problem. But when they're double or more than double what they're supposed to be, then we're talking some problems. And these are resistors right on the dual horizontal output tubes. So the cathode resistors, the grid resistors, supposed to be 100 ohm, 131, not terrible. And this is also supposed to be 100, and it's more like 250. So, yeah, replacing those four resistors fixed up those horizontal issues. Now the focus is horrible, and that's because, so I've said a million times, it's because of this. This test CRT is not supposed to have that. Often I've been able to unmount it, disconnect it, move it to the side. This one's kind of huge. Not kind of, it is huge. And it has some kind of beefy mounting on it, so I don't really want to unmount it. But I'll see if I can, because I really want to check everything thoroughly. Because with that big metal cone CRT installed, it's really hard to check anything. For example, we have this spring-loaded knob. You push this in and turn this to adjust a control inside here. Imagine that metal cone CRT being here with 15,000 volts or so on it. Not really the kind of thing you want to reach around and make an adjustment on with your knuckle right next to that high voltage. So I'd really like to. Likewise, there's a trimmer pot here. Imagine you got that metal cone coming right down through here, and this entire bar has 15,000 volts on it, and you want to adjust that. Not so much fun. Or these coils here. So I think it's worth taking the time and effort to either bypass this or the power resistor or unmount it. Oh yes, much better. It actually wasn't too bad to get off because there's a decent length of wire and it's modern compared to some of the stuff I've worked on lately. In other words, the wiring is not all crunchy, crusty, cloth covered. What a difference that makes. So let's see. Now if I do the so I'm doing the height switch. So when it's set up properly, it should be like a 4:3 aspect ratio, but when you're in porthole mode, full height mode, it extends up. So obviously the vertical linearity is off, but nice. Let's do a little more aggressive pattern. Ooh, nice. Nice bandwidth. Just in the fine tuning. Back off on the contrast a little. Wow, yeah, I mean, we've got, let's see. So that's 4 megahertz on the far right. So we got too much width, at least with this CRT. It's going off the screen to the right. But we've got pretty good definition out here. It should make a really nice sharp picture. Let's feed in some live programming, shall we? Oh yeah. I like what I'm seeing already. Turn that contrast down a little. That is an outstanding picture. Just fine tuning a little. I think it was pretty darn good right where I was. That is a really, really good picture. So, I think we got it. We got it. I need to clean up a little bit of work underneath. I tacked in the last couple caps here. I want to do a terminal strip. So you may have noticed I did not use adapter caps on this. No, because these are all twist locks, and I didn't want to drill holes and muck with it. So, I should say I drilled a hole for a terminal strip so far, and I'll probably have to do a second one. Otherwise, I was able to find existing lugs and grounding points to put the new electrolytics in. And keep in mind, it's made it easier because the main power supply electrolytics over here. So a lot of these cans, notice how short these are. They just have 1 or 2 caps inside of them. This guy, I think, this guy only has 2 caps inside. So there actually aren't all that many electrolytics I had to deal with in here. But yeah, boy. Really. Here's how I'm mounting the new electrolytics. This was a 3-section. I found an area of the chassis nearby where there was nothing mounted above. Drilled a small hole, used a self-tapping sheet metal screw attached to the new terminal strip, and mounted my 3 caps. Similarly, we have 2 here. I drilled a hole. I'm going to mount the terminal strip here and mount these 2 new caps on it. And put one here for these 3 caps. This is how I've been running the setup till now, with these just tacked in and kind of floating in space. Not a very safe way to do it, so we'll clean that up and then call this done. And as always, I am closely supervised while I do all this work. And here we go with the full-size CRT. I had a fight with the ion trap magnet a bit and let it warm up for a while. It seemed a little tired at first. It was a little overdriven. Looked kind of more like that. But after playing a few minutes, things settled down. So this is in full porthole mode. If you flip the switch, cuts the height a bit and you're closer to 4:3 aspect ratio. So really up to the viewer. Do you want to have maximum screen inches of viewing area with people stretched a bit, or a little more realistic? It's so deceptive being around this thing because There's no ozone, there's no crackle. I don't, the hairs on my arm aren't standing out, probably because it's kind of humid. But if I, if I brush into that, it's 15,000 volts. Wham. Man, so I have to keep reminding myself as I'm reaching around, adjusting things, keep one hand in my back pocket, and keep a healthy distance away from things as much as possible. It's so weird compared to the glass CRTs where you've got some thickness up front and you can see the image from the other side. This is so weird. It seems magical, like a looking glass or something. Imagine if you were a kid and you saw this, it would seem so much more magical than a conventional glass CRT. It's just like a metal cone with an image just appearing at the end. Alright, so fantastic. I'm gonna reach around and turn this thing off without getting anywhere near anything dangerous. Okay, cool. So there's that. Power switch. It's stuck in the on position. I'll disconnect one end of it and try to work that switch back and forth and seize it up. So I'm missing the inner knob. This is the outer knob, which is contrast, which I don't quite understand why the contrast is going to this number. I mean, did people like really write down what contrast setting they were using or something? I just assumed when I first saw that this would be the volume. No, the volume and the power is the inner, and I'm missing that knob, but I can dig something up. I'll probably just use what was on there when I got it, which was an Admiral knob that fits and works okay until we find the, hopefully someday, the proper knob. But anyways, it's that inner knob. Here I can do with a screwdriver that so that switch is just stuck on. So, well, working that power switch back and forth was getting me nowhere fast, so I just took the plunge and unmounted it. Didn't want to because there's a dial string that goes to a pulley around this. And I noticed that dial string is getting frayed, so I should probably replace it, much as I hate doing that. Anyways, so these two sections appear to be fine, the two rotary sections. The switch is bad. It sure looks to me like the only way to get into this switch is from this side, which means I need to undo the top deck to get to the bottom deck to get to the power switch. So it's all got to come apart. I just said this 3 times in a row. I really don't want to do this. But it's either this or I'm not going to find a replacement control. It's way too specialized with the way the knobs mount. I'd really like to get this power switch working. I'm taking the controls apart before. It's not the end of the world. I just want to be really careful not to break these tabs off so we can put it all back together. This is CTS, so one of the big players, and they sold all sorts of kits so you could assemble your own controls or repair them. So, like if the switch is fried, there's a chance I might have one or can get one from somebody that would be an exact match. But yeah, the way these are held together is these metal tabs that bend over and lock in. And then the same with the sections down below. It's just you can't get at the tabs for the lower sections because they come up inside this. Notice how this one is bigger than that one. The tabs for this one are inside this cavity. So we got 6 in total we have to remove. Jeweler's screwdriver. Yeah, let's get in there. Still get that one up. This guy. Yep. That's the ticket. Oh, I just kept at it with a knife and scratched it up a bit, but I was eventually able to start getting these tabs bent up. So there's the second one. Just use this guy, which is the hardest one to get at. It's just getting that first little crack started that's so hard. Once you do, it's easy. There we go. Okay, which reveals nothing really. So the switch contacts are going to be underneath this. And how do you get that open? No. Yeah, I was wondering about that. So the shaft on this mechanism is pushed through the phenolic and then spread open. I don't know if you can even fix this. So I think replacement might be the way to go. Unless maybe these were gummed up a little. Seems like there's some little metallic residue bits in here too. Let's try the continuity check again. Hey, no continuity. Just flip it the other way. Now we have it open in both. Oh wait. Oh no, I slipped. Okay. Now it's now open in both directions. Well, awesome. Well, I'm done with this. Even if I got this working, I don't trust it. It's not worth messing with anymore. And it looks so familiar. I went and jumped onto eBay and searched for them, and nothing came up. And I did a general web search, and nothing really came up. And then I went looking through my junk box, and immediately I found a bunch. CTS Type GC, 3 amp, 125 volt, super common. So I could scavenge it from one of these controls, maybe this guy, or this one's actually never been used. I'm not crazy about sacrificing a new old stock control with a loudness tap though and a power switch. And then I saw this. Look familiar? It's exactly the same control with the inner shaft with the fluting on the or knurled on the end. It's exactly the same value. Same switch. I must have parted out a porthole chassis ages ago, or got this out of somebody else's junk box who had. It's all the right values, and the switch works, and all the pots work. So a few minutes of searching just saved me a whole heck of a lot of time. So we are going to transplant this control into the set. That's why I save everything. New control is all wired in. It works just fine. Volume, power, and contrast. So, we are just about done. So glad I found that control. Alright, so that's it for the major electrical work. We're going to pick up in the next installment with a whole lot of cosmetic work on the cabinet. Thanks for watching.